Now we're going to solve logarithmic equations using the equality property. If each term of an equation has a logarithmic expression, you condense each side to one log expression and then use this property to solve. If log base b of m is equal to log base b of n, then m is equal to n. So let's solve each equation for x. Looking at this equation, notice that log base 7 of 3x plus 5 is equal to log base 7 of 8x minus 12. These logs are already condensed. The 3x plus 5 would be like the m in the property, and the 8x minus 12 would be the n. So let's set those equal to each other and solve. We're solving for x, so let's subtract 3x from both sides and add 12 to both sides. 5x is equal to 17. Divide by 5, and x is equal to 17 divided by 5. The next equation has a 3 in front of the log. This 3 represents the exponent, and we need to condense this log and bring the 3 back to its spot as an exponent. So now we have x cubed log base 2 of x cubed equals log base 2 of 27. So x cubed would be the m and 27 would be the n in the property. X cubed is equal to 27. Remember from exponent unit that I am solving for x. This is x cubed, so I can multiply both powers on either side of the equation by 1 over 3. So on the left-hand side, we're just left with x. On the right-hand side, we're left with the cube root of 27. And the cube root of 27 is 3. Another way I can look at it is x cubed is equal to 27. I can raise 3 to the third power to equal 27. So x has to equal 3. In this example, the right-hand side is not condensed, so I need to condense the right-hand side. So the first thing I want to do is move the 2 to its spot as an exponent. I have log base 2 of x equals log base 2 of 3 squared plus log base 2 of 5. Well, 3 squared is equal to 9. So I have log base 2 of x equals log base 2 of 9 plus log base 2 of 5. I'm not finished condensing the right-hand side yet because there is a plus here. So remember, the first thing we do is take care of our exponents. Then we want to change any pluses to multiplication and any minuses to division. So I have log base 2 of x equals log base 2 of 9 times 5, because we're using the property that says log base b of m plus log base b of n is equal to log base b of m times n. This is from our previous lesson. So now the logs are both condensed, so we have x equals 45. Notice the left-hand side needs to be condensed. I'm going to use the property that says log base b of m minus log base b of n is equal to the log base b of m divided by n. This is from our previous lesson. So we have log base 8 of 48 divided by x equals log base 8 of 4. Now I have m and n. The 48 over x is the m and the n is the 4. So we could set these equal to each other. 48 over x is equal to 4 over 1. Now we have an 8th grade proportion problem. We can multiply using the butterfly. 48 times 1 is 48 equals 4 times x. And then divide by 4, x is equal to 12. Notice we have to condense the left-hand side of this problem. So from left to right, let's take care of the multiplication division first. Reading from left to right, I have a plus sign right here. So I'm going to use the property that says I can multiply the m and the n together. Log base 7 of x squared, because x times x is x squared, minus log base 7 of 3 equals log base 7 of 12. I'm using the property that says when there's a minus sign in between, we can condense by dividing m and n. So this was m, and this is n. Log base 7 of x squared over 3 is equal to log base 7 of 12. Now this is m, and this is n. The base and the log are the same on both sides of the equal sign, and they're condensed. Set the m and n equal to each other. And remember, 12 is the same thing as saying 12 over 1. X squared is equal to 36. Take the square root of both sides, and x is equal to plus or minus 6. But the answer is x equals positive 6. Remember from our previous lesson that you cannot take the log of a negative number. Next example, we have to condense on both sides of the equal sign. So let's look at the left-hand side first. On the left-hand side, there's just a minus sign separating them. So we will use log base 2 of 2x minus 1 divided by x plus 5. On the right side, we need to move the 1/2 to its exponent position and the 2 to its exponent position. So I have log base 2, 36 to the 1/2 power, minus log base 2 of 2 squared. The left-hand side is still good, but the right-hand side still needs to be condensed. Now 36 to the 1/2 power is the same thing as saying the square root of 36. We have our base raised to power divided by root can be rewritten as the root base inside the underneath the radical symbol raised to a power. Log base 2 of 2x minus 1 over x plus 5 is equal to log base 2, remember 36 to the 1/2 power, which is 6. So this is log base 2 of 6 minus log base 2 of 4. Still need to condense the right-hand side, and we get log base 2 of 2x minus 1 over x plus 5 equals log base 2 of 6 divided by 4. Now we have our m and n, so we can set those equal to each other and solve. 2x minus 1 over x plus 5 equals 6 over 4. Let's solve for x. 4 times 2x minus 1 equals 6 times x plus 5. Remember to distribute to both terms inside the parentheses. 8x minus 4 equals 6x plus 30. Subtract 6 from both sides and add 4 to both sides. We get 2x equals 34, so x equals 17.